These are the 9-5 notes for inscribed angles. This definition of an inscribed angle was on your exploration. An angle whose vertex is on a circle and whose sides contain chords of the circle. So what you should have found is the measure of the inscribed angle is equal to, let's see if I can get this right, half the intercepted arc. Okay, and some of you wrote that a little differently. You wrote the arc is twice the angle. It's the same thing, so as long as it makes sense to you. If two inscribed angles intercept the same arc, then the angles are congruent. Ooh, look at that. Okay, and that should have, I heard a lot of good conversation in the computer lab. A lot of you saying, well, the angle is equal to half of the arc. Well, if they intercept the same arc, then they're half of the same thing, so they have to be equal. An angle inscribed in a semicircle is and hopefully you said a right angle. A semicircle is 180 degrees. If the angle is half of 180, it's a right angle. If a quadrilateral is inscribed in a circle, then its opposite angles are, change the color again, supplementary. Again, this was one you should have found. I heard a lot of really good discussion about this. If you look at the opposite angles, together they intercept the entire circle. So if they equal half of their intercepted arc, and together they intercept the whole circle, well, half of 360 is 180. We can talk about that more when we come back to class. Okay, you also should have found the angle formed by a chord and a tangent is also equal to half the intercepted arc. So I guess as we go through different types of angles, we had angles at the center, they were equal to the arc. Now any angle where the vertex is on the circle is going to be half the measure of the intercepted arc. So I have some pictures here to try and help you. Angle ABC is an inscribed angle. It's made of two chords with a vertex on the circle, and it's equal to half of arc AC. So this angle is equal to half of this arc. If you look at angle XYZ, again, kind of think of it as a giant crocodile mouth. What part of the circle is it eating? It's eating this. Oops, sorry. So it's half of this arc right here. So instead of, I would always focus where is the vertex. If it's on the circle, it's half of the intercepted arc. Okay, where's the intercepted arc? The intercepted arc, if you think of kind of this as a big, like I said, crocodile mouth, it's the arc the part of the circle it's eating. So there are some examples here. I'm going to show these. And if you have the printout notes, you can fill these in and work through these. If you're drawing them, you can push pause now and copy these. Okay, and you could push pause, and copy these. And I'd like you to work through these on your own and then come back and push play and see if you got them right. All right, for X is here. Okay, so that's the measure of this arc. And so I'm going to go, okay, here, if I follow this up to here, this angle is 20. Well, the angle is half of the arc, so X must equal 40 because that's twice of 20, 2 20s. For angle Y, again, I'm going to follow that out. You could use different colors if that helps. Okay, when I follow angle Y out, it is inscribed vertex on the circle, so it's half of the intercepted arc. Okay, well, the angle Y is intercepting this blue arc. So it is half of 110 plus 40, which is 150, so Y is equal to 75. All right, over here with O as the center, you're going to see this is a diameter. Angle Y is inscribing a semicircle, so angle Y must equal 90. Half of 180 is 90, and we kind of did that. For angle X, if I follow that out, and I go from here to here, it's intercepting this arc, but I don't know that arc. However, this one, let's see if I can even do a new color. Let's try some purple. Intercepts the same arc. So if this angle is 20, this arc must be 40. Angle X must be equal to that angle because it intercepts the same arc. Angle X equals 20. Ooh, I'm a big fan of the purple. Love that. Okay, as we work down here, this angle is 60. So that's going to make this arc 120. Since the circle is 360 degrees, this is 120, this is 140, that's 260. That is going to make, what do I try here? This arc 100. All right, angle X is not marking here to the curve. You can't, remember what angles are made of. They're made of two rays, and a ray isn't like a part of a circle. So angle X is this chord and this tangent. Okay, angle X, if you kind of draw your line out. Okay, so that is intercepting the 120 degree arc, so angle X must be 60. For angle Y, again, angles are made from rays, so it can't be from this chord to the edge of the circle. That's not what angles are made of. So angle Y is intercepting the arc that's 100, so angle Y is half of that, angle Y is 50. Angle X is going to be 40. If this is 180, this arc, because this is a semicircle, this arc must be 100. Oh, bringing something back from the previous sections. Equal chords. Equal chords mean equal arcs, so this one must be 100. Because they have equal chords, they have equal arcs. And Y is going to be half of that because it intercepts the 100, so Y is equal to 50. We have one more set of examples. So again, I would ask you to please try these on your own. You can push pause now to copy the top two if you need to. Okay, if you need to copy this bottom one, go ahead. Okay. Try those on your own and then push play to come back. Okay. The 80-degree angle, and again, for some of you, this very visual way of drawing that out is intercepting this arc. 80, X must be double that, so X is 160. Now, X, Y, and Z together make a 360-degree circle. Okay, so this used up 160. I have 200 degrees left for the remainder. Well, these have equal chords, so Y and Z must be equal. I have 200 degrees for this arc, so I'm going to divide it equally amongst Y and Z because they had equal chords. So Y is 100 and Z is 100. Okay, X intercepts the 60-degree arc, so X is half of that, which is 30. Equal chords here and here. So if this is 60, that leaves the remainder of the circle with 300 degrees. Since these are equal chords, that remainder of the arc is split equally. 300 divided by 2 leaves 150 degrees for Z. Down here, okay, let's see if I change the colors up a bit. 82 is out here, so this big arc is 164. This big giant arc over here. 164. Now, angle X is pretty easy for me to find, but a lot of you might forget. We just figured out in a quadrilateral inscribed, so that quadrilateral is inscribed, opposite angles are supplementary. So to get X, it's just going to be 180 minus 82, which equals 98, if I'm doing that right. So angle X is 98 degrees. Now, to get Y and Z, I'm going to have to work with the arcs. Again, equal chords. So I'm going to do 360 minus 164. That should give me 194? 196? Hold on, I probably did that one wrong. So, is that right? 364, so... No, 196 sounds right. And then this splits equally, so that leaves 84 for each. So 42, does that sound right? The other piece I could use here is 82. Y and Z are 180 degrees. 182 is 94. Or I'm sorry, 180 minus 82 is 98. Y and Z are both equal because if you look, equal chords equal arcs. So they're both half of equal numbers. So that would leave Y being okay, I might have done the calculations here wrong. So if you have this done, you'll be able to work on some problems when you come back. I will also teach this lesson live on Friday, so if you didn't understand, you can ask some more questions then. Enjoy your snow day.